Well, it's wonderful to be on a walk with you here today. Thanks so much for coming with me.
Thank you so much for inviting me. It's really an honor to walk with you today, President Wente. I'm a professor in the physics department and I have been at Wake Forest for 15 years. I'm also one of the founding members of the Center for Functional Materials. So this center was started in 2018 with support from the Provost Office. And it's meant to be a platform to help catalyze and accelerate research that is materials related.
Right. We said one of my favorite words there, catalyze.
Exactly. I didn't realize that. You're right.
So how did you get interested in this area of physics?
I think I always wanted to be a scientist. My mom is a physics teacher, was a physics teacher. She's retired now back home in Romania. So her lab was my playground when I was little, right? I was never afraid of, trying things. So that's why I'm an experimentalist. So I really love doing physics, but I also really love teaching it. So you see why Wake Forest is a really good home for me. I'm excited to be in a place where I can do world-class research, but at the same time, my efforts in teaching and mentoring are also valued.
So tell me about your classroom. What's the environment like?
Yeah, so I teach both undergrad and graduate level classes. Every student should be treated with respect, no matter if they struggle or if they are really brilliant. You need to tailor your teaching style depending on the level of the class, right? An undergraduate level would be approached differently than a graduate level class. And then even within the one class, every student is different. So really trying to tailor your teaching such that in the end they learn, because that's the key, what they have learned. How have we impacted their life after Wake Forest?
So how do you gauge students' success? Do you have any specific things you look for or think about?
There's some important skills that I would like my students to really learn while they are at Wake Forest. For example, I want them to approach every problem in life with the mind of a scientist, right? To be these critical thinkers. Another important thing that I try to inspire is to always challenge what they know, or better said, what they think they know, and be ready for surprises. And in particular for research, to accept that failure is part of the research progress and to maintain their research integrity through the failures. And also important is the communication. They need to be versatile communicators. They need to communicate equally well with people from their own discipline, people from other disciplines, but also with non-scientists. That is very important to communicate to the broader society, right? To communicate clearly and in a way tailored so that everybody can understand.
I hear your message about communication and how that's so critically important, and this next generation really embraces a lot of different communication approaches. So you mentioned in there students in the research lab.
Mm-hmm.
Tell me how you bring those students into your research.
My group consists of undergraduate researchers, graduate researchers, postdoctoral researchers, and also during the summer high school students. These type of vertically integrated research teams are very powerful, and I really think that innovation can come from every level. I encourage them to speak up if they have an idea, and let's discuss the idea and see how that can be applied, right? The research that we work on has to do with printed and flexible electronics. So for example, traditional electronics that we have in our phones, computers, homes, cars, and so on, they are made out of inorganic semiconductors, like silicon, for example. These type of materials have very strong internal bonds called covalent bonds. So to process these materials, one needs to invest a lot of energy. That means high temperature, high vacuum. This is not only expensive, but it also limits severely the substrates that you can deposit on. So these type of applications are usually made on quartz or glass. They are rigid. The materials we are interested in are called organic semiconductors, essentially a kind of plastic. So they have all the amazing attributes of plastic, low cost, ease of processing, but at the same time, they allow electricity to flow. So now, instead of heating to like 1,000 degrees to process these materials, we print them. We can put them on paper, we can put them on plastic, even on fabric. Then applications that can span out of it would be rollable and flexible displays, wearable electronics, electronics conformal to any part of the human body for medical applications. So hopefully electronics everywhere that will change the way we interact with technology and improve the quality of our lives. This is really what attracts them, the possibility for future applications that we can enable. And then they discover that it's actually not as easy, right? So there's a lot of things we don't know. There's a lot of things we need to learn to make these materials suitable for these kind of applications.
Really, you're offering our students a lot of life lessons as well as physics lessons.
I'm definitely trying. They learn how to work in a team, they learn how to communicate with each other. So it's really growth on so many different levels when they work together in the lab. The most important thing of what I do is really, making an impact to the students that are trained so that they go out there in the world and make this world a better place in the spirit of Pro Humanitate.
Well, I'm so proud to hear that. I'm proud to hear how you are thinking about the impact on society, but really in terms of how not just you make an impact, but how all of your students are making an impact.
Right, because it amplifies. So it's like, it's amazing, right? We have such a power to training these people.
No, you're a catalyst.
Exactly.
Well, thank you for being on this walk with me today.
Thank you very much again for the invitation.